Hello everyone. So we will wait for 5 to 10 minutes and then we will start since I can see that not many students have joined. So we'll wait for 5 minutes and
Yes,
then we'll start.
yes.
Okay. Okay. Hi everyone. So let's start the session. Mm, yeah. So today we will be studying assignment 1, assignment 3, week 3. Previous year we will be solving previous year's assignment 3 and so sorry you guys had to wait for 15 minutes, sorry for that. So chalo, let's start then. And try to solve this question. So for a given high frequency circuit, figure 2 with input signal V in having resistance Rs, the value of circuit's components are Rg is equals to 800 kilo ohms, Rs is equals to 200 kilo ohms, Gm is equals to 9 milliamperes per volt, RL is equals to 10 kilo ohms, CGS is equals to 1 picofarads, CGD is equals to 0.5 picofarads, CL is equals to 20 picofarads. ठीक? Now it's asked find mid band gain. Okay, sir has given the exact formula in the lectures. So you have to find mid band gain and overall time constant of the circuit. So this is pretty big question and take 10 minutes. आराम से solve करो इसको, ठीक है, since there will be many KCL, many KVL you have to do. So आराम से इसको solve करो and take 10 minutes and I want answer from everyone. Okay, so I will tell you the method. So for mid band gain V0 you have to find that you can get for overall time. ये वो तो हो जाएगा, formula ही है directly, you can do that. For overall time constant, what you have to do is you have to short circuit all the voltage sources and you have to open circuit all the current sources. You cannot do anything for the independent sources. So you have to keep independent sources, but current and voltage sources have to be short circuited and open circuited respectively. And for different capacitors you have to open circuit the other capacitors. Okay, so now try to solve this one. I'm giving you 10 minutes. Okay, and I want answer from everyone. Note down the circuit. पहले circuit note down कर लो. How much time is left? How much time did I give you? Okay, I will give you 4 more minutes. Option
Option
C.
C.
Okay, very good, very good. What about others? Done? बाकी लोग क्या हुआ बताओ? Have you guys not covered this week's lectures? Hmm? क्या हुआ? What happened? Or mid semesters are coming and guys are busy with that and not getting time to. क्या हुआ? Why I'm getting?
Ma'am,
Huh?
can you solve the RGD part?
RGD. Yes, yes. I'm going to. I
Mm.
will. I will solve RGD part. Uh, so okay, that's good. At least you are solving. What about others? You didn't. How many of you didn't get a chance to read this week's lectures? Okay, guys are not going to reply. Anyways, ठीक है. चलो, we'll go. Okay. So here we have to find out VO, right? So what will be VO? We will. Uh, okay, tell me. बहुत तूने सॉल्व किया है. How to solve VO?
we can directly take the formula, ma'am. Sir has
Yes.
given that formula for gain.
Uh-huh.
That is equal to minus GMRL into Rin by R plus Rin. That is the direct formula given for midband gain.
Mm-hmm. But don't you think like by that, if you do like that, then if circuit changes, then you won't be able to solve. Okay, कोई बात नहीं. Yes.
I have opened all capacity, then calculate the P. Then
You are not. I'm not able to
yeah,
get you. Okay. Yes. 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 I got you. Yes. That's the way to solve this question. So what we will do is we will open all the capacitors. So here it's open. Here it's open. And here it is open. So what it becomes here is something like this: V in, right, RS, RG, right. So RS, RG, V in, and here it's a VGS, right. So how much VGS will be? VGS will be something like this, right? RG V in upon RG plus R in, RS. Any doubt here till here? Any doubt? See, we got like this, and we will find out VGS. Apply simple KVL here and we'll get this, right? Any doubt till here? Now the since this part is open, right? Now we have to deal with this part. So this part is something like this. GM, we already know VGS, and RL, and at this point we have to find out V0. Any doubt here in the equivalent circuit? Any doubt till here? No. ठीक है. तो this is how we got V0, value of V0, which is something which is like this. uh, we will put the value of VGS in and we'll get the value of V0, and then we'll find out the what we have to find, mid band gain. So mid band gain will be V0 divided by V in, right. Mid band gain is V0 divided by V in. So we'll put it here. We got V0 divided by V in minus 72. Now let's go to time constant estimation, right. So time constant estimation is summation of C I R I. Okay. So there are three capacitors: CGS, CGD, and CL, right. So yeah. So we'll see here. है ना? So we have three capacitors CIRI. So first we'll find out. So for CGS we'll find out RGS, right. Till here, you have any doubt till finding out the mid band gain? Any doubt till mid band gain? Oh, okay. Let's go ahead. So CIRI. So here we have to find out. Now we have to open circuit all the capacitors. All the capacitors are supposed to be open circuit. All the voltage source are supposed to be short circuit, and all the current circuit are supposed to be open circuit. but it is only for the independent sources. Dependent sources you have to keep it as it is. So here we have opened the circuit. From here we are trying to find out the R equivalent for this circuit, since it is not completely uh, it's not connected at all with this part of the circuit. So we will leave this circuit, and we'll only find out, we will leave this circuit out, we'll only find R equivalent for this circuit. Any doubt here? So RS and RG will be in parallel, since RS and RG both are grounded, and we can short circuit it here, and something like this will become RGS is equals to RS parallel to RG. Any doubt till here? No. Okay, so let's go ahead now for CL. For CL, okay, so for CL we have to find out the equivalent circuit for equivalent resistance for this. If we are going to again open these and short circuit this one. So when we short circuit V in, then when we short circuit V in, then VGS will also be here. VGS is there, right? But when we are short circuiting VN, there is no source, so VGS is also 0. So when VGS is equals to 0, then GM-VGS, the dependent current source, will also become 0. Hence, if this becomes 0, this means it's a the this becomes open circuit. So it is open circuit here, only RL. So R equivalent is equals to RL. R equivalent equals to RL. Any doubt here?
No, ma'am.
No. Okay. Let's go ahead now. uh, let's try to find out CGD. So for CGD we have taken some variables and some variables, and we have open circuited and short circuited as required. So here we get something like this. The circuit is something like this. Any doubt here? Look at it, what we have done. So from here we have to find out R equivalent. From equivalent, looking from this side, right? And we have taken the potential drop from this point to this point as plus Vx, plus minus Vx, right? And here we have taken the current flowing through this part as I1. Okay, so what we get here, so R equivalent, firstly R equivalent will be Vx by I1, right? Now let's make a KCL, sorry, KVL. So in this circuit, right? Why I'm making it like this? Because only these values we have, uh, uh, we know the, either we know the voltage, or we have assigned it to some variable. Okay, right? Getting it?
Ma'am,
Hmm.
can you explain this part from beginning, because I disconnected.
Okay.
Only RGD part.
Yeah. Okay. So here what is happening is, see, this is the equivalent circuit that we have got from here to find out RGD. So what we have done is, we have open circuited this, we have open circuited here, all this we have short circuited this one. So something like this we are getting. Now we are assigning some variables to some points, like we are saying that here the current flowing in uh, this line is I1, and the potential drop here is plus Vx. Here the potential drop is already given, VGS, and we have also taken the potential drop here as plus Vy, plus minus Vy, and the resistor here is already RL, and we have taken the current flowing in this direction as IY. Okay, so the R equivalent will be Vx divided by I1, right? Any doubt till here? Now we will, any doubt?
Ma'am.
No. Okay, so now we will see for parallel. We already know that for parallel branches voltage drop is same, right? So let's apply KVL here in this. Since this is parallel only, we can already say that this, okay, making it like this might confuse some of you. So it's only, right, and since it's a parallel, so here it will be plus minus Vy, right? So the first equation is minus VGS plus Vx plus Vy, right? So Vx became VGS minus Vy. Another equation is another uh, another equation will be, okay, so I1 current is flowing in these two branches. We can find out, so the R equivalent for this will be RS parallel to RG. So voltage here will be VGS will be I1 into RS plus RG. Any doubt here? RS parallel to RG, not RS plus RG. RS parallel to RG. Since voltage will be same for the parallel branches, right? And for the equivalent resistor also, voltage drop will be same, right? So this is what we have got. VGS is equals to I1 RS parallel to RG. Any doubt? Now let's put now let's put KCL at this node. So KCL will be plus I1 plus GMVGS plus IY is equals to 0. Since all of these are going away from the node, you can take assume your polarity as you want. Not your polarity. You can assume the current's polarity as you want. Here I have taken going away from the node as positive. So I1 plus GMVS plus IY is equals to 0, right? Now we'll put the value of IY. So IY is equals to minus I1 plus GMVGS. IY is equals to VY by RL, as we already know. And here we have got I1 plus GMVGS, right? Now VY will transfer RL here. I1 plus, now we'll put the value of VGS from equation number 2. We got this. We'll take out I1 also. So no, yeah, so Vy we got something like this, right? Now we will put the value of Vy and VGS in terms of uh, in the equation 1 for to find out Vx. So Vx is equals to VGS, which is I1 RS parallel to RG, plus, it was here minus, right? So minus minus plus plus I1 RL 1 plus GM RS parallel to RG. So Vx divided by I1, will take I1 common from both these equations. Vx divided by I1 is equals to Rs parallel to Rg plus RL plus RL GM Rs parallel to R4. This is R equivalent for CGD. That means this is RGD. Any doubt?
No, ma'am.
Okay. So yeah. So this is what we have done here. Uh, so overall time constant will be RGS plus RGS CGS plus RGD CGD plus RLCL. So we got around 7645 nanoseconds. So option number C. C is the correct option.
Once can you display the previous page?
What? What you want me to display?
Can you please display the previous page which you about the
Um, what you want me to display the answer this thing?
yes, ma'am. Yes, ma'am. One second. This one only.
Your voice is getting disrupted in between, so I'm not.
Yes, ma'am. This one only.
Acha.
I
Okay.
want to note down the formula. 1 second. Thank you.
So any doubt here, anyone? So now that you know the formula and everything, you have to solve this question. For sorry, from the circuit of question 5, question 6, find the upper 3 dB frequency and gain bandwidth product. You have to find out upper 3 dB frequency and gain bandwidth product. Done. What's the answer?
My option B.
Okay, very good. What about others? What others think?
Option D, ma'am.
Okay. Chalo, let's solve. So okay, 3 dB frequency is asked. We have already given time constant is already given to us, right? So time constant diya hai, we'll put it. We got omega 3 dB. So now we got omega 3 dB. Now for frequency we already know 2 omega is equals to 2 pi f, right? So we'll put, we know omega. To find out f, we'll divide it by 2 pi. We got 20.82 kilohertz. Any doubt here? No. Okay, now gain bandwidth product. So we have already got the bandwidth. We already know the gain. We'll put it, right. We know the bandwidth 20.82 into minus of 72 modulus, so 72. So we got 1499.04 kilohertz. So option number B. So very good, guys. So let's go ahead and try to solve question number 8 now. For the circuit given in figure 2, for question 6, find RL such that 3 dB frequency becomes 25.809. So 3 dB frequency becomes 25.809 is the question. So how you have to solve it is, you have to again find out, you know the time constant, you know the frequency. You have to trace your steps back and you will be able to find out the value of RL. Okay, go ahead, try to solve this one.
Ma'am,
Hmm.
ma'am, can you tell the CGS, CGD, GM values?
Huh? What? Acha, the formula.
Ma'am, can you tell?
Haha. Okay.
Uh,
Yeah. So here,
not formula,
haha.
values. CGS, CGD values.
Values for, so here it will change now. For this 25.8009 kilohertz, value
Yes,
will
ma'am.
change. So you have to trace it back. So this value will change and then you have to find out the RL. So what you have to do here is, you know the overall time constant is something like this, right? So here, uh, you frequency is given to you. Now you have to convert it into time constant, then into this formula, into put it here in this formula, and you will be able to get it. But not exactly this, the expansion of this, you have to then expand it to find out the actual value of RL. So you have already solved, right? So see, RGS, these are the formula. Now find out RL.
Option B.
Option, yeah. Uh, what about others? What others think? Okay. Oh, option A is the correct option. Let's now try to solve this one. Okay, as I said, so now f bandwidth is given to us, right? So from bandwidth we'll convert it into omega 3 dB. Then we know that time constant will be equals to 1 upon omega 3 dB. We'll put that, right, and we got 6164 nanoseconds. Understood? This is what I was talking about. You have to find out, if bandwidth is given to you, have to find out the time constant. Now you got the time constant. Now the formula is time constant's formula is summation of CIRI, right? So now put all the C and all the values of RIs. So that is RGS, CGS, RGD, CGD plus RLCL. So this, then expand it, which will be something like this. Now RL will be, now from here you have to this is simple arithmetics. You have to find out, you will, yeah, convert it into the RL equation. So here something like this. So this will be the, got it right. Now tau is given in terms of RL and all the other values are given to you. So you will put it and something like this will be the equation, and then RL will be 8 kilo ohms. Okay, any doubt here?
Ma'am,
Huh?
why we are considering here CLRL also?
CLRL, because time constant is summation of CIRI na. So
But in the formula, in the previous case, there is no CLRL.
here it is na. See, see here.
Oh, okay, okay. Yes, yes.
Hmm. So that's why. So any other doubt, anyone? No? Okay, let's go ahead. Okay. For the value of RL in question 8, so now you have to put the value of 8 kilo ohms as RL. Find the new mid band gain. So now find the new mid band gain. You have already the formula and everything in terms of RL and, right, other variables. Put the new value of RL and you will be able to find out new mid band gain. So what will be the answer here? Done. 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 Okay. So same formula is already given to you. Now our new RL is 8 kilo ohms, right? And V0 by V in is minus GM RS RL upon uh, RG plus RS, right? RG RL divided by RG plus RS. So we'll put all the values and we got the new mid band gain minus 57.6. So answer option D is the correct answer. Any doubt here? Hmm? Any doubt? Okay, no doubt. So let's go ahead. Question number 10. Let's try to solve question number 10. According to the Miller's theorem, what is the impedance in input and output port if I1 is equals to 20 milliamperes, I2 is equals to 40 milliamperes, and Z is equals to 2 kilo ohms? So Miller's theorem you would have already studied. Now, what is the impedance in input and output port if I1 is equals to... So there are formulas given in the NPTEL lectures, right? So you just have to directly put the formula and get the value. I1 20 milliampere, I2 40 milliampere, and Z is equals to 2 kilo ohm दिया हुआ है. अभी पता, you need to find this out. I'm giving you 2 minutes. Directly put in the formula and you can get it. डन एनीवन? किसी का हो गया क्या? हाँ, सो स्टूडेंट्स लेफ्ट, ओके। किसी का हो गया क्या?
No, 1 minute.
Yeah.
Option C.
Option, which one? Yes. No, no. Option A is the correct one. Okay, let's go and see. Okay, so impedance in input port will be 1 plus alpha into z, right? Z is given to us, alpha is given. एक second. हाँ. So first we have to find out the value of alpha, which will be equals to I2 divided by I1. So I2 divided by I1 will be 40 divided by 20, which is equals to 2. Z here is 2 kilo ohms. So now put it in the formula. Z in 1 will be 1 plus alpha into Z, which is 3 into 2 equals to 6 kilo ohms. Similarly, input impedance for output port will be 1 plus alpha divided by alpha into alpha, right? Which is equals to 3 by 2 into 2 equals to 3 kilo ohms. Okay. Any doubt here? Any doubt? No. Okay.
Take the link of the session, ma'am.
Yes, yes. I will. What you want?
Link of the session, recorded session.
Acha, link. You want me to share it right now?
Hmm.
Okay. 1 second. To stop sharing. So here is my YouTube link. You can go here. I will upload it. I will upload the recording sections soon as I can. Alright. So, acha, tell me one thing. So when we uh, uh, do this doubt solving session, so like I'm doing this doubt solving session for assignment 3, so is there is it possible that the deadline of assignment 3 is already passed, or you have some time to solve assignment 3?
This assignment date is already passed, ma'am.
Okay. Okay, so I don't know, maybe some mismatch is going on. Anyways, since yeah, for I guess we are going 1 week late, uh, by maybe something happened. Anyway, some mismatch might have happened. Anyway, so all the best for assignment 4 then, and I will meet you next week. And I hope that you have got good marks in assignment 3. No,
Yes, madam.
how was your assignment? What about others? Okay. No one is.
I think it will be good if the present assignment session clues will be given.
Hmm.
Like 15th is the due date for third assignment
Hmm, hmm,
actually.
hmm. But
If it is just before 15, then we could at least get some idea.
hmm, what?
Like last two questions we were unable to solve.
Okay, and what about other TAs? So other TAs will also be taking live session, right? So what do they do?
Ma'am, to be frank, your session will be very clear, one to one. We will exchange formulas also.
Hmm.
Your session will be crystal clear, ma'am, because I've been there for the other two sessions also.
Hmm.
The syllabus will be same.
Hmm.
That's why I stopped listening to Tuesdays
Hmm.
and Saturday session. It will be almost same.
Okay.
But your session will be very clear.
Okay, thank you for that. Okay, ठीक है. So maybe some mismatch has happened. Anyways, because we were also given credentials little late, and so I was thinking that maybe what is going on, why. So maybe their plan is that since uh, assignments, the previous year assignments are also mostly new assignments are also similar to, the questions are similar to the previous ones, so maybe because of that they don't want to us to give this doubt solving session before the deadline passes. So maybe that is the case. uh, Anyways, ठीक है, all the best for assignment 4. Bye bye.
Thank you, ma'am.
Thank you, welcome.
Hello,
Thank you.
hello.
Yeah. Yes.
Madam, are you going to continue the tomorrow session also?
No, no, another TA will be giving another tomorrow session.
Mhm. Madam, are they going to discuss regarding week 4 or week 3, ma'am?
I guess they are going to discuss week 3, since this is the third week we are supposed to give the session. So yeah, most probably he is going to give third session, third assignment.
Madam, can you discuss regarding week 4 also?
uh, Week 4, I, so that is the thing. So I do not know if this is like, if NPTEL team decided to do this, I have not, I no idea about it. Probably they decided to do this because they don't want us to give the answers, right? If we can if we are solving assignments, right, and the deadline has not passed, then we will be directly giving you the answers. So maybe because of that they have planned something like this, so that you read the lectures, you attend the assignments, and if you are not able to get correct answers, and if you are not able to score well, then you will have doubts for those questions in the assignment, and then you can attend this doubt solving session and clear your doubts. So maybe this is
Okay.
their, yeah.
Okay. Thank you, ma'am.
Okay, all the best. Bye bye.